We've reviewed how we take the carbon-hydrogen bonds in our energy-yielding nutrients, the protein, the carbohydrates, and the fats, the triglycerides, and breaking them apart so that we end up with ATP that we can go spend. But now I want to talk a little bit specifically about feasting and fasting. When we eat more calories, more energy than what we need, and then when we don't eat enough to meet our needs. And how does the body adjust these pathways to fit those guidelines? We have a few more terms here that we'll think about as we go through this as well. So first of all, feasting. Feasting, I think, is a little bit more intuitive. People kind of understand it already. But sometimes after we go through energy metabolism and you kind of look at this, it almost looks like a funnel where you just pour these energy-yielding nutrients into the system that you think you might just rev up that TCA cycle and end up with more ATP so that all of this gives energy. And we want to separate that out from really the idea of we get more energy. When we eat more calories, we eat more energy. But it's not that we end up with more PEP or ATP that we can spend. Really what happens, we know, is that when we eat more calories than what we need, whether it's from our chicken, whether it's from candy and potatoes, or whether it's from butter and olive oils, that we don't get more PEP, we get more body weight, we get more body fat. And so that's why understanding that when everything gets to acetyl-CoA, that's that center of metabolism. When you eat more energy, more calories than what you need, more food, you will break things down to acetyl-CoA and it starts building up. You cannot force the TCA cycle to go faster. What will happen, you'll build up acetyl-CoA, and then that acetyl-CoA will come over here to form these fatty acids. We'll get some pyruvate being built up, and now we can build triglycerides, which will be stored in our body fat. And that will be the case whether it's protein, carbohydrate, or food fats. You know, we get it to the acetyl-CoA and we can shift it over here to body fat. So any energy-yielding nutrient, we take in more than what we need, we are going to gain body fat. Now fasting is a little bit different because fasting is, we have to always be thinking from now until we die of starvation if we're going to be in extreme fasting. We always have to have two key energy-yielding nutrients. And so what we need here when we are fasting is we will always need a source of energy. Just life is going to take energy. Well, that one's pretty straightforward. We've got triglycerides. We've got even a very, very thin individual will have about 100,000 calories of stored energy stored in body fat. So that's going to be our source of energy, body energy, from now until we die. And if we die from starvation. If we think about the other thing we need to have, though, it's glucose. You will always need glucose because some tissues in the body cannot use these fat-based molecules for energy. We've got to have a source of glucose. So we can think about where can we get our glucose. Now to begin with, we can get it from glycogen. And this would be any time you don't have enough carbohydrate or you haven't eaten in the last 3 or 4 hours, you're going to have a stored source of glycogen that the body can break down, and that can be converted to glucose. This last, we have about a day's worth, 18 hours worth, so our beginning source here is going to be from liver glycogen. So our first source of glucose is going to be liver glycogen. We do have glycogen in our muscle, but the muscle does not release its glycogen back into the blood. So this is going to be our liver glycogen. I'll add that here. So that's going to be our source. But after about a day, it's going to be gone. And we will need a source of glucose until we die, until things are not working as well. So we look at these pathways and we can see that glucose, we have this pathway here, and I've got one down arrow here represented as opposed to a bigger arrow coming here. And the reason why I did it that way is because this is reversible. We can take pyruvate back up to glucose. We cannot take acetyl-CoA back up to pyruvate. It is an irreversible pathway. But this one we can. And this has got a title. It's called Gluconeogenesis. So here's one of our terms. And if we just look at that term, genesis is the beginning of new glucose. So that is going to be from pyruvate. And if we look at what is converted to pyruvate, what could go back up there, we have two things. We have glycerol and amino acids. Glycerol is a very poor source. Okay, so a poor source of pyruvate to produce glucose. And the reason for that is because every time you get one glucose molecule, it's going to take you two glycerol, two of these three carbon molecules, and you end up with all this fatty acid that ends up down here to acetyl-CoA. It's more than what the body needs. So this is a very poor source. It can work that way, but it's very limited. So now we come back over here to where our other source, it's amino acids. If we're fasting, or we have a very low carbohydrate intake, our source of amino acids will be from our body proteins. It can be from our food as well. We can have a protein-sparing modified fast. But primarily, if someone is starving, they're going to be using their lean body mass to break down the amino acids to convert it over here to glucose. And this will be something that we will do until, if someone is starving to death, they will do that until they die. So that is going to be another source. It's going to be body protein or food protein, body or food protein, will be our source of glucose until, to form glucose from this process called gluconeogenesis. Now, it's important to understand that if the rate of which we do this, if you have not eaten any carbohydrates or you haven't eaten for a day and you've used all your liver glycogen, you are using this pathway so fast, you're using so much of your body protein to produce glucose that if nothing else changed, you would probably die in about 2 weeks. That's how fast we are going through our lean body mass. In fact, you probably die with quite a bit of stored energy because we're just burning through our lean body mass so quickly. But in reality, we can live about 2 months without eating. So, can't last real long, but that's a real change from 2 weeks to two months. And the reason why is that we have an adjustment, a process called ketosis. I want to put this here. Ketosis is the process of taking acetyl-CoA and converting it to ketones. Okay, that process is called ketosis. So we've got these two terms here. Ketosis is the condition of the process of taking acetyl-CoA and converting it to these molecules called ketones. Now, why is that important? That's important because our brain that loves glucose for energy, if it has to, it will use ketones. So when we have this shift, and this will shift in about 2 to 3 days, 2 to 3 days without adequate, this will start. Without enough carbohydrate in our diet, we will actually have this process going. We'll have ketones be upregulated into our blood, and now the brain will actually start using ketones for energy, which reduces the amount of glucose it needs in the body, and now we will have to have less production of glucose from amino acids because of that shift in the brain's use of that energy pathway. Now, one of the things is that I've talked about starvation. So if someone has no glucose in their diet or they're not eating it at all, we can see where we're getting our energy. We can see how we get our glucose short term and then longer term, and then this subtle shift over to needing less of it because of ketones. But anytime you don't have enough carbohydrate in your diet, or you can't get carbohydrate inside a cell, you will have this process going on. So starvation is there, but in a very low carbohydrate diets, so Atkins diet, those types of diets, we have so low amount of carbohydrate in our diet that we're going to get in ketosis. And the other condition is diabetes, uncontrolled diabetes. And the reason for that is all of this is happening inside a cell. In a diabetic, they have lots of glucose, but it's in their blood, it's not inside the cell. And these pathways are all happening inside the cell. So fasting is going to have this process where you're thinking about where you get your energy, where you get your glucose, and that answer is going to change, whether it's the first day of fasting, it's the second day of fasting, or if it's a week of fasting. And all of those things, when we look at energy metabolism, we look at how we can these are interrelated, and what pathways are common, and then which ones are reversible versus irreversible. All of that is important for understanding energy metabolism.